Good afternoon, everyone. Today I'll be exploring the connection between inorganic chemistry and skateboarding by representing the 5d orbitals with some skateboarding tricks. So first of all, I'm going to start with this pop shove it. This is a 180-degree turn of the skateboard across the x and y axis, aka the ground, exactly like the x and y plane in a d orbital. My idea with all of these tricks was just to represent the shape and orientation of each orbital. In real life though, electrons don't just evenly spin around an orbital. Something crazy that I found out while recording this is that skateboarding tricks and atomic orbitals actually line up because they're both following the universe's easiest rotational modes. This is because they both need to spin in a natural, energy-efficient way around something in order to actually work. This next trick is meant to represent an XZ orbital. So that's an X with a Z attached, so it goes up a little bit. So in order to do that, I did a Casper, which is kind of like a shove it, except you go up. So just like the z-axis, you're going up instead of sideways, like that y-axis. In order to do this, you need to turn your board upside down. This next trick is the coveted kickflip. No, I cannot do one yet, but we're getting there. I thought the kickflip would be a cool representation of the YZ axis because it's a diagonal motion upwards along with you going forwards, so you need to stay in a single plane in order to do the trick. When I was coming up with these tricks, I was actually thinking much about the octahedral crystal fields. So these T2G tricks, or I guess orbitals, actually cost less energy to perform than the EG tricks, which are the ones coming up. For example, I decided to represent the x squared y squared orbital with this revert into a fakey shove it. That's like a backwards shove it. So it's very similar to the xy orbital, except the revert makes me change my angle into a different angle, much like the x squared y squared orbital. This last trick is a body varial shove it. So while he does a regular shove it, in which his board goes 180 degrees in one direction, his body is actually spinning 180 degrees in another direction. And it's going straight up. Much like the z squared axis, it goes straight up and spins. And the board does a donut-like rotation under him. Unfortunately, even though I asked, he would not breakdance under the skateboard, so there is nothing spinning under the skateboard. So really, this is kind of like the top half of a z-squared orbital if you split it along the xy plane. Thanks for watching, guys. I had a lot of fun making this. Be sure to wear a helmet next time you guys shred some inorganic chemistry.